Hi, welcome to this Open Security Summit in March 2022. And here we're going to have Luis, which is going to talk to us about open security control testing at scale. Over to you, Luis.
Thank you, Ines. Thank you for having me today. I will try to go faster at the beginning of the talk because I think that there is a lot of stuff to present today. Okay, so let's start. Okay, who am I? I'm a telecommunication engineer. I work in BBVA. Last 22 years working in BBVA, involved in security risk assessment, in SDLC. I was the builder and head of BBVA Global Security Center. That was the trenches, but now I'm leading the innovation in security department inside of the global architecture team. BBVA, what is BBVA? It's a big company, a big bank. It's a hybrid sector. We have a lot of different environments and projects and a big bet on security. Regarding innovation labs, we look for new questions. We apply a practical approach. So we try to find out new answers. And learning by doing and doing to learn. So it's something that it's in our core. Also, we have some. We are multidisciplinary. We want to be multidisciplinary inside of our team. The project team it's composed by me and by Roberto Russo. And Cesar Gallego. We love open source. We open source most of the work in innovation and security. So you can find out in our repos some stuff that we are presented today will be in the Susto repo. So you can find more about it, and it will be updated because the latest add-ins are not yet in the public repo. Okay, so an easy index, just trying to solve the relevant questions for you: the what, why, who, and how. Firstly, what we want to solve. Okay. Threat modeling is fun, but controls, I think it's the most valuable outcome and the core of our work. We need to treat controls as first-class objects, like other parts of our system functions. That is something that Phil Venables, the CISO of Google Cloud, recently wrote. He also wrote about how we need to, like any other code, we need to test controls and test them as early as possible, preferably at build time when we are integrating or deploying our new versions. And also we need to declare a control incident if a control is not function as intended. And finally, controls citizenship has been finally recognized by OWASP with their 4 point of insecure design. That reads part of the insecure design item is write unit and integration test to validate that all critical flows are resistant to the threat model. So it seems that we need to do something with this. And indeed, we have checklists. We have OWASP ASVS, we have PCI DSS, sometimes, like in PCI DSS, we have testing procedures. So it's not only the checklist, but how to test. And sometimes even some actual test for some environments, like in AWS, we have some specific rules to check against PCI DSS requirements. Okay, with detailed results. And the last one that I want to review is NIST SP 853 that demonstrate that a test set can define a control, as a test set can define a business feature when you are developing regular software. So this is the first step towards a definition of DOM with security controls. And also NIST, by the way, is introducing an interesting approach with instantiation. There are some different parts of the checklist that are setting apart independently of each test. But they fail to provide an executable testing mechanism. Is test select from mechanism for implementing account management. But how we can do this? Okay, that's the what. Let's see why automated testing matters. Okay, as security practitioner, I want to be the best in class tools to be ahead of any attacker. But the real problem is IT shops, led by devs and merged by absorption with ops that have been accelerating for years, using agile short test cycles, continuous development, continuous testing, continuous integration, continuous delivery, continuous deployment, continuous monitoring, and setting velocity as one of their main KPIs. So what we really need is to keep pace of the rest of IT. And automation has brought new risks too. Everything is or will be code. And this automatic instantiation is the fuel to achieve the velocity. We are moving from work orders to other departments with implicit rules and implicit controls to explicit code defining what we want. So explicit software defined everything needs explicit and automated control checking. Fail to do it will drive to automated user errors. Automation is good, but if you fail, you are automating your errors. Or as a last argument, you need to comply. And I remember you that OWASP top 10 is referenced in some standards like PCI DSS. Okay, let's see who will work to achieve this automating testing. First, clearly, this is not a solo climbing journey. It's difficult to do it alone, but it's also difficult if we don't organize how we do it. In the past, we struggled to explain our vision of a community approach for automated security testing. So let's organize and write a script. Here you are, the main characters that will perform our automation. First one is Matt Rule. Matt Rule is a rule creator. He's familiar with NIST, OWASP, PCI, controls, and best practices. He's an abstract thinker. He's not worried with implementation details, and he will to collaborate with the community. Okay. Analista is a security risk manager. She's a threat modeler. He assesses the controls to be deployed, several from a formal or informal catalog of common controls or best practices inside of her organization. She maintained the same risk posture across different projects and environments, but has no vision or control over whether her instructions are followed or the effectiveness of the controls she established. We also have Presley Leeds, that is the project tech leader. She's a project or service or environment domain expert. She knows the information needed, but not always how to gather it. She was able to parameterize rules, but she's risk assessment agnostic. We also have Victor Studio. He's a developer. He's a project or service or environment domain expert. He knows where the information is and how to gather it. He can program the gathering logic. He can write code to gather the information he needs, but also he's risk assessment agnostic. Finally, we have Norman Auditore. He's the auditor. He follows the standards, but interprets good practices. He, without a clear definition of done, he always will find findings on control selection or implementation. Usually, he checks control manually by himself. He doesn't trust others to do his work. We have other characters. We have Ernesto Aplicado, that is running the application security. Seri Watson, working at attack surface reduction, or the CIRT response department. Kalinda, she's a pen tester. Iga, that is identity governance, and Maria de la Norma, who works in compliance. So maybe you can identify yourself with one of them, but sorry, the film is not about you. We want to try to see the full picture. Okay, let's see now how others did similar things. To begin with, the approach and tools devs are using to speed up and increase in reliability is continuous delivery, acceptance test-driven development. It seems that we need some kind of automated security control regression testing. So why don't we just do the same? Why don't we just write a acceptance test for each control in our organization? Okay, well, because they scale. Choosing NIST controls, best practices, we have more than 1,000 controls to meet. We have some checks per control, defining the definition of the control. But also we have different environments to check, because in the control and in the check, you can find accounts. Accounts means different things if you are thinking of local machine, your Active Directory, your LDAP, if it's your cloud provider, or your IoT. Sometimes we deal with the same or similar concept in different controls. Let's see if we can use this as a lever. And in addition of the best practices of the controls, you will have organization and project specific controls. Yet, write unit and integration tests to validate that all critical flows are resistant to the threat model. We have a problem with the number of the security control checks we should do. There's a overwhelming number of tests that a single organization should develop, and it is make difficult to start a project that would require a high development and maintenance cost. So to deal with the scale and diversity, we try to reuse and compose. Standardizing interfaces. If different pieces can match, we can build something bigger. We can compose and build almost everything. Maybe designing and building some special pieces like the wine skins or the rocket engines. If we follow some basic typing. And we can share with others. If we design and build a new piece, we can share with others. Others can use what we have done. Okay, so this is something that resembles to a community, because sharing is caring. We have successful community projects in security, like Snort, like Yara, like Sigma. And right, I think that this is a pattern. Sigma is for load files, what's Snort is for network traffic, and Yara is for files. So it seems that maybe here is a hidden pattern. What's the pattern? Okay, the pattern is we share patterns to match data. Let's see if we can use it later. Okay, so let's start with the core of the talk. How we can do this at scale. Okay, let's start with the ideal status quo of from abstract security requirements to the test that we need to launch against our systems. There's a complex journey from generic control objectives to automated test. And this is something that we already know in regular programming in our projects. There are product owners that establish requirements. There are technology providers that provide us with different interfaces. And our product must match this business logic to that abstraction logic. So this is the matching. The matching is how we can find a way to match the what for and the how for. But we lack a way to share the logic. So let's see some examples to try to find patterns in controls. Okay, this example is a simple control that among all users in a Linux system, only root may modify the files etc password, etc shadow, etc groups. We have another possible control that among all web app or user, only admin users may modify the user table. Or among the all IAM users, only those with admin role may have permission to add new users. This is something that can be a pattern here. Among all, only may in the to. So does it resemble functional programming? We have functions, we have different sets. Maybe we can use this later. We can build some abstract, but more matching closer than a checklist, right? In Word, that we now have a way to describe in a functional way what we want to check. It will be different instantiations, but this seems to be keys. First abstract, later instantiate. But this is very difficult to organize at scale. So let's see our cast in action. Matrul, Analista, Preslilith, and Victor. The example we have chosen is an IAM control for the sake of common understandability, to show universality of the approach, universality of the approach, and to try to debias against other common security testing tools, static code analysis, network threat testing, system hardening, because that caused us some problems in the past to explain the approach. Okay, so Matt translate test to rules. He established who will fill the blanks in the rules. Those accounts are disabled when the accounts have been inactive is what to check. It's all must have property when. She will formalize the abstract logic of the check, and he will establish how each parameter will be set. This is an example of rule that it's translating to a more matching, readable rule. All accounts, and we will see later what is the meaning of the dollar. All accounts must have status equal account state to disable when account inactivity period is greater than max disable period. Okay. She's establishing what parameters will be used at each stage. The G dollar, it's a parameter that will be gathered later. The CH is a check parameter that will be risk established with the desired values or thresholds setting by the security analyst. The check parameters will be immutable across rule expansion, and it could be maximum CVSX, expire time, minimum version, something that will be set later. This rule will have a hash, fully identify the rule, the authoring, and the relevant data to be unique and searchable across the system. Anna, it's remember, is the security analyst, instantiates the check parameters that are risk dependent. Remember that NIST have defined specific parameters, specific variables to be defined in the organization, like time period within which to disable account, and the time period for account inactivity before disable is defined. So these are the risk threshold parameters, the risk appetite of the organization. They will be the check parameters. In our case, for example, we have the max inactivity period, what is the type time duration days set at 21, and max time to disable set to 3. And she also established that the max disable period is equal to max inactivity period plus max time to disable. With all of this, we have a new ID that is the check ID. So we had the rule, now we add some parameters that are risk dependent. Then Presley, she instantiates the parameters types based on system used in her project. She instantiated the rule to their particular environment. In our case, she's establishing that she's using an AWS, so the types for account is AWS user. The user status, it's also a specific type for AWS, and also she adds some environment execution specific parameters needed to gather the info, like the AWS keys that will be necessary later. Some gathering functions code are already in the catalog. Okay, so with all of this, she can try to see if she has all the data and all the functions she needs to complete the rule. But there is no our system cannot derive a function between AWS user status, that is the type of account status is disabled, to the Boolean that we are expecting. Remember that the types are derived from the different definition. We don't need to state directly in each definition which is the type. If the system can derive the type, the type will be automatically set. So we have Victor at the rescue. Victor can write a function that if you provide the user status, the function can deliver a Boolean returning user.is account active. So this new function is added to the catalog. And now, being in the catalog, this new function can be used by other controls, by other rules that also use rdisable, rdisable, rdisable. This is one of the magic of the system. And finally, if there is another project that in which accounts are not in AWS, but in Active Directory, other projects can reuse the code, the check params, logic, and most of the types used. So this is the full picture from the standards and best practices that are text to rules made by Matt that Anna instantiate according the risk appetite. She has assessed the different controls, and so she can match and establish which test will be used to check each control. Then Presley add the instantiates the project specific parameters. Sometimes there is a missed path to the target, so somebody needs to write code to complete the execution path. Then you execute the rule and obtain the results and the audit trail. The results will be fed back to the application security requirements and modeling tool. So Analysta can now see what is the status of their controls. So let's run it. Let's see what we will obtain at runtime. We have the rule. We have the checklist. We have the rule. We have the check parameters. The parameters. So we now can start to run. We will start with the rule ID, the check ID, the params ID, and the test ID. So when we have all of this, now we can obtain the result. The result will be true or false, and a reference of the all outputs and inputs, including parameters and test function used to run the test. And here comes the power of the community to scale, because we can decentralize the work. The work is uncoupled. There is no coupling between different actors. They can work in different projects and organizations. So there are not just one math rule. There are several math rules. There is not just one Victor studio. There are lots of different Victor studios. So both rules can be written independently from the testing code, but keeping the risk appetite and prioritization decisions inside of the organization. And with loosely coupling, cooperating with projects, with project technical leaders. And most of the work can be safely shared across the community. Most of the hard work can be shared. If you can see the standards and best practices, we already have it. The rule definition is something that is more or less straightforward. It must be done. It's a hard work, but it can be done independently. So we can parallelize this work. The technical instantiation, most of the instantiation can be done also independently, or even started by the cloud provider or the Red Hat or the different big providers, technology providers. And the gathering code can also be independently right. A Victor or Victors can interface existing code, because a Victor won't write an static code analyzer. He will use one, but the results of the different existing tools, he can interface, he can gather the relevant information to fit the rules. But if you have some specifics in your systems, you can write small scripts, small code to test specifics of your project. What is kept in your organization? Most of the automated results, the executions, the audit trails, the projects, the different instances of your projects will be kept inside you, but you can share the rest. So let's see what can be done with the execution results. Who and how will consume the results. First, Norman, then Presley, that she can feed back the CI/CD. She can use the results of the role execution to stop the line if something is missed, something is wrong with the controls. And Presley now can manage project security at the pace unlike the rest of her system. And also to help Anna, Sari, and Maria to know the real status of the controls, so her CISO can sleep at night. Okay, so it seems that now we have a way to share the logic. But how? This is something that is sorcery? Oh, let's see how we have done it. That was the problem, that how to match the what and the how. And let's see if our kids are doing or can do something similar. If you know App Inventor, your kids can define global and local variables and get and set them. That was the different parameters we are using. The dollar parameter, that is a generic and unrestricted parameter that we establish at root definition time, but that will be resolved at compile time. We have two special kinds of definition parameters that are check and gather. Check parameters are the risk established desired values or thresholds. They are immune across rule expansion. And for example, can be the minimum version, the maximum CVSS, the expire time. You set the specific parameter to match your risk appetite in your organization. The other main parameter in our system is the gather parameter. That's how we instruct the system to obtain the data the system needs to go to the next step. This parameter cannot be set manually, but gathered at runtime. For example, which are the IPs in a VPC, which are the files in a directory or bucket, which are the registry values. And the last one is the execution parameters, that it's some arguments that are needed to run the test, like authorization data or the bastion IP address, something that is not the core of the rule, but that will be needed to run the test. So the technical lead needs to instantiate that parameter in order to obtain the final data. And what App Inventor does, he matches the different key values or the different mechanisms, the different types that he needs. Your kids cannot construct a sentence that is not viable, is not correct with App Inventor. This is something that it's done by inside the App Inventor. So in our case, what we brings to our system is how to do automatic type matching. You can define and bring your own types. This is the magic of the system. How to resolve the different types that each step needs in an automatic way. Because what the system is doing is pattern matching of types and functions, not pattern matching of data like Snore, Yara, or Sigma. And finally, the sorcery, how all this magic it's done. So we start with the rule file. We have a first pass that it's a query constructor that validates the rules syntax, check the constraints of the different parameters, and keep track of the different IDs. The output is the query execution intent. And then we have another system that composes the test, builds the execution path, searching for expected types in a graph. So if there is a path between what I need and how we can obtain it, it will generate a valid program that match all the different types. So the output of the test composer is the text execution plan, and then we will need a text executor that deals with the real world execution of the code, that audit every step, and we can do this in a distributed execution, because the plan is you can write the text execution plan and distribute the different parts to different executors, and we will obtain the results file and the audit file. So this is Sorcery. No, this is SUSTO. This is Systematic Universal Security Testing Orchestration. You can find some of the work in our public repo. We are just ending some of the previous parts of the system. the query constructor, the test composer are in a POC state, but they run. But the final step, the executor is something that we need to work more on it. And that's all. Questions? Question 4. For different roles, at least working on building this control seems like a dream come true. Why are so far away from all of this? Where are we failing? I think that we know that we fail communicating the scope and the goals of the project. We started some years ago, before the pandemic, but it's difficult. It's difficult to explain, but also it's difficult to reach the conclusions that we know now how now to do it. We have done several POCs with different approaches and with different steps that haven't a data ends. So it's something that is difficult, and the second difficulty is that bootstrapping a community, it's difficult. I think that let's see if from now we can build a community around this. And it's a problem of building too little standard architectures that allow us to favor decentralization at some points. I think it is now a problem of architectures. I think that we are applying a Pareto approach with security controls. We think that, and it's the approach, for example, of OWASP top 10. It's a Pareto approach. And testing, security testing at build time mainly, we are also using a Pareto approach. There are different companies, there are different startups that are focusing on the big ones problems. But we know that there are lots and lots and lots of very small failures that can bring the full system down. So it's difficult to, when you see the scale problem, you see, you can think that it doesn't. It's something that won't pay. Okay. Is the initial effort to get that first MVP rule set too high? Yeah, it was. The problem to integration of this control. I think that integration is will be the less difficult technical part of the problem, but will be the most difficult organizational problem, because always if we need to bring the DevOps, these technical leaders that are applying DevOps, are applying ATDD to this approach, and it will be difficult, that part. Any other questions?
I think if there's no more questions, we'll leave it there. Thank you very much.
Okay, thank you.
Thank you.